All right. And then at the end, we'll have the evaluation and data form for you to fill out. And with that, I'm going to stop sharing and I'll turn it over to you, sir. Thank you.
Thank you, Michael. All right, give me a quick second here to share my screen. All right, and then whoop, can everyone see my screen then?
Yes.
Perfect. All right, thank you. All right, welcome everybody. Happy Tuesday. My name is Andrew Scanlon, as Michael was saying. I'm a instructor here at St. Francis University. I've been teaching kind of on and off for about the last 6-7 years. And my specialties are teaching biology with a focus on environmental. I teach environmental studies, and I also teach a lot of the introductory biology courses, and also the anatomy lab. So I kind of fluctuate between human health and environmental biology, where I tend to, I find have more fun doing the environmental stuff. So the title of my talk today is Managing Nutrient Pollution in the Chesapeake Bay Watershed. So we have a couple objectives here today. By the end of this presentation, you should be able to familiarize yourself with some of these terms and concepts. Today, we're going to learn about which nutrients are often of concern for the Chesapeake Bay. And we're also going to talk about dead zones and why and how they occur within the bay and how times that's in response to these nutrients coming into the bay. And then we're also going to talk about what are called total maximum daily loads, a lot of times abbreviated as TMDL. And then with talking about Chesapeake Bay, I'd also like to focus on Pennsylvania and Pennsylvania's role in managing nutrients within the bay. On the right, and throughout this presentation, you're going to see pictures. I credit most of the pictures where I found them off the internet, and some of the pictures I shared from my own personal catalog. The pictures of the streams that you will be seeing here are streams that are very close to St. Francis, and a lot of these waterways will eventually travel into the Chesapeake Bay. And as Michael was saying earlier, we do have a little bit of snow on the ground, which is why you see some snow there. Don't know what it's doing in Maryland, but hopefully it's a little bit warmer. All right, so the outline for this particular talk is we're going to talk about nutrients and algae, the relationship that is between them. We're going to talk about dead zones. We're going to define dead zones, why we should be concerned about them. And then we're going to talk about those total maximum daily loads, those TMDLs. And then we're going to talk about the importance with those in the Chesapeake area to help manage nutrient pollution and all that stuff. And then we're going to talk about how Pennsylvania has implemented TMDLs and what does this necessarily mean for the bay. Okay, so a little bit of background. As I mentioned before, I've been teaching at St. Francis for about, like I said, 6 years, 7 years. But why do I have interest in the Chesapeake Bay? You may be wondering why is someone in Western Pennsylvania interested in the Chesapeake Bay? Well, part of my graduate research was at Penn State University, and I studied algae growing in streams all across Pennsylvania, particularly the algae that was growing in streams that eventually go into the Chesapeake Bay. So you can see a picture of me up the top, right here. Growing some algae on blocks, and we're trying to calculate total maximum daily loads, TMDLs, which I'll talk about later. And then also, I took a lot of classes down, marine biology classes down near Wallops Island, Aztec Island, Chincoteague Island, which I know is not necessarily part of the Bay watershed. It's kind of, a little bit to the right there of the Chesapeake Bay. But I have a real fondness for the Chesapeake Bay, and I usually like to take my family down there, once a year to Maryland. So I really enjoy the Chesapeake Bay. So with that, I do have my first question here. Michael, if you don't mind popping it up. You guys, if you don't mind answering a question, what nutrients are responsible for algae growth? And, select all that fly. So take a few seconds. And I think that's everybody. All right. So looks like you all got it. So A+ for everyone here. The answer is the nutrients that are most concerned or which allow algae to grow are phosphorus and nitrogen. So very good, everyone. Let's close that. Oh, we're gonna say something, Michael? All right.
Oh, sorry, I left no, actually not. Continue. Sorry.
Perfect. No problem. Thank you. All right. So very good. So we all know that phosphorus and nitrogen are very important in growing algae. There's also micronutrients in there as well. But when we come to managing algal growth, we typically look at phosphorus and nitrogen the most. So nitrogen and phosphorus, as many of you know, are required for plants to grow. So they're very important within growth of plants, algae, and then you can see here we've got some skunk cabbage growing. This is actually behind our university here in some wetlands. This is very vital for these plants to have adequate access to these resources. Traditionally, phosphorus is found in the soil. It's typically locked away within the soil. And then nitrogen, fun fact about nitrogen, is the most abundant gas in the air, so within our atmosphere. Our atmosphere is about 78% nitrogen to 21% oxygen. So oxygen is not the most abundant gas in our air. It's actually nitrogen gas, with about 1% carbon dioxide. So why am I talking about nutrients such as nitrogen and phosphorus? Well, nitrogen and phosphorus are very important in algal growth. And one thing, if you have too much of nitrogen and phosphorus, too much of a good thing, can lead to what are called algal blooms or algae blooms. An algae bloom is defined as this large growth of algae. Usually you see them sometimes growing depending what state you're in or the time of year, usually in the warmer months, so maybe late spring, oftentimes early summer. And it's just characterized as just algae upon algae growing on top of one another. Algae blooms do reduce water quality, so they reduce clarity. There's also some other chemical things they can do to the water as well. And the rapid growth of algae can consume oxygen as well. And I'll talk about why that is in a minute here. Here we have a picture of an algae bloom in a lake, and you can just see just all this green stuff. That would be your algae. So some algae we need to be more concerned about than others. Within these algae blooms, phosphorus and nitrogen may tend to promote the algae that is best able to utilize those nutrients and grow the quickest. Excuse me. So we can have what is called toxic algae. So on going from the left to the right here, left we have a microscopic what's called cyanobacteria. Technically, if you want to talk to an algae person, it's not considered algae, it's actually considered a bacteria, but it can photosynthesize. It can produce toxins, which can be detrimental to pets and people. We also have green mats of algae here, and then maybe you've heard of red tides, brown tides, which is produced by different types of algae. All three of these can come from what are called harmful algae blooms, or HABs, and there could be illnesses associated with them. So sometimes you get different colors of green, sometimes different colors of red, depending on the toxic type of algae will determine the different type of color that it has. So algae blooms actually can be a common occurrence, could be a natural occurrence. However, with the advent of things such as fertilizers and stormwater runoff and agricultural runoff, we get an influx of nutrients into waterways that typically aren't naturally there. And we get just, unnaturally large algae blooms. Lake Erie usually has an algae bloom sometime in the summer. Here, just for reference, is Cleveland down here. Erie would be in the middle up here, with Buffalo up towards the right there. All this green dark area you see here is algae. This can cause problems with water clarity, people that fish, people that swim. Doesn't necessarily mean this is a toxic algae bloom, but this is a satellite image that you can actually see from space. So this algae bloom is quite a big problem. This was taken in 2011, and usually every year there's an algae bloom in Lake Erie. They can kind of predict it based off of the rains and how much water inflow is coming in to the lake. So with all of you being from Maryland, probably familiar with algae blooms in the Chesapeake Bay. Here we have a satellite image provided by NASA. Excuse me. You can also see some algae growing here in the top portion of the bay, or I guess the middle, top portion, middle area of the bay. These green areas, that would be the algae. You can see all this sediment runoff. The sediment runoff is coming from many different rivers, many different watersheds after probably a rain or storm event, and is one reason why it's making the water look so cloudy. So within all that sediment could be nutrients, phosphorus, nitrogen, could be contaminants such as pesticides, herbicides, and things like that. This picture was taken in 2011. So why should we be concerned about algae blooms? If it just caused the color change in the water and didn't do anything else, then maybe not much of an issue. Consequences of algae blooms: not all algae blooms have toxic algae in them, but if they do, or typically if there's an algae bloom, it can lead to beach closures. So this is top left here is a beach closure up in Vermont due to blue-green algae, so cyanobacteria that I was showing you earlier. And then if it is a toxic algae bloom, can also lead to beach closures as well. Here we have a fish that's been killed by algae. Couple impacts of these toxic algae blooms could be skin irritation. Individuals that are prone to respiratory problems are typically affected by this because the toxins that are produced in these toxic algae blooms sometimes become airborne or aerosol. And if you inhale them, it can irritate your lungs or nasal passages. It can lead to throat, eye irritation, vomiting, and stomach pain. That's just being exposed to it, not if you actually ingest a fish or something that was exposed to these algae blooms. Usually you can have more severe abdominal cramps and diarrhea and things like that. All right. So what are some of the sources of nutrients in the Chesapeake Bay? What are some areas of concern, or where are all of these nutrients coming from? A lot of it's coming from agricultural runoff, water treatment, effluents, water treatments, sewage and things like that gets processed through a water treatment plant, and then that water has things are removed from water. Effluent has to go somewhere. Typically, it's dumped into a stream or a river. Stormwater runoff: anytime there's major storm events, water is going to go off the streets. If it doesn't go through a stormwater system, it could just directly go into the creek. And typically, these nutrients are going to be used in growth and photosynthesis. So these plants rely on these nutrients to grow and perform photosynthesis. So the nutrients that don't get absorbed by these plants are washed into the watershed and will lead directly into the bay. So Michael, we have the second question here. Question 2, I believe it's a true or false question. So true or false? Does algae consume oxygen? Oh. We have 1 true, 2 false. All right. Well, the answer is true. Algae actually does consume oxygen. So we're going to talk about why that's important here coming up. So a lot of people, when they associate photosynthesis, one of the byproducts of photosynthesis is oxygen, right? So algae, trees, they release oxygen during the day. However, at night when photosynthesis isn't occurring, because photosynthesis occurs in sunlight, plants will actually consume oxygen for fuel their cellular respiration, make ATP and things like that. So algae actually do use oxygen. They produce a lot, but then they also use some. And that becomes important here. So good work when we're talking about dead zones. So what is a dead zone? Sounds like a cool name for a metal band. A dead zone is an area of little to no oxygen within the water. So an area of little to no oxygen. Doesn't necessarily mean there's no oxygen. Could have a little bit, but usually not enough oxygen to support vertebrate species. So fish, crabs, I guess a crab's an invertebrate, but very little oxygen. So these dead zones are created when algae die after it blooms. So you get the growth of all this algae over, late spring, summer months, and then eventually that algae is going to die. So as that algae dies and sinks to the bottom, it's going to start to decompose. What's going to decompose it is bacteria. So this bacteria, as they're decomposing that algae, are going to consume oxygen. Also, as I mentioned earlier with our true or false question, algae will use oxygen at night as well. So you have decomposing of the dead algae, and then you have the algae at night utilizing oxygen, and it drops the oxygen down in these areas. So fish and crabs, which are mobile, can swim or crab walk out of the way of these zones, while oyster, clams, or shellfish cannot. So it can be very detrimental to industries such as shellfish industry. Picture here on the right is taken by the Chesapeake Bay Foundation. You can kind of see this cloudy looking area there. That's where the dead zone is. So if you were to put an oxygen probe into the water, the oxygen level within that water would be very low, if not zero. So what is the occurrence of dead zones? So during the spring, late spring, or just during spring and March, typically is a wet month here in Pennsylvania. You get rainwater washing all these nutrients into riverways, and that's going to fuel these algae blooms. When those algae start to die, as I was mentioned earlier, they're going to sink to the bottom. They're going to start dying. Bacteria is going to start decomposing them. Dead zones, depending what the lake is and the contours of the lake, if it's a shallow lake or deep lake, dead zones typically occur later in the summer when the water is typically warmer. These bacteria like warmth, and then when the water is calmer as well. So the Chesapeake Bay does have instances of dead zones. According to Virginia Institute of Marine Sciences, the average dead zone within the Chesapeake Bay is about 1.4 cubic miles. The dead zone in 2021 is the last one I was able to find data on, was about 1.5. So last, big one was slightly larger than average. The largest one ever recorded was in 2011, which was 2.7 cubic miles. Now, just for comparison with other dead zones around the world, this dead zones in the Chesapeake Bay aren't as big as other dead zones. So the Arabian Sea is the biggest dead zone that occurs in the world. It would have 63,700 square miles, so roughly the size of Florida. And then the Gulf of Mexico has a very famous dead zone that typically occurs every summer. It's about 6,000 square miles, which is the size of New Jersey. So the dead zone in the Chesapeake Bay isn't as big as these. It's still concerning, but just kind of to put things in perspective. So this is showing data from 2020, looking at oxygen levels within the Chesapeake Bay. So on our graph here on the right, we have hypoxic waters. So hypoxic is like very little to no oxygen. So our oranges and reds here, and then looking at our dissolved waters at like 10. So if you have a 10 for 10 milligrams of oxygen per liter, that's relatively healthy waters. So the areas that tend to have the lowest amount of oxygen within the bay tend to be within the middle to upper region of the bay, not so much where the bay tends to open up. So this was taken in 2020. and then during this year, the actual dead zone actually decreased more than normal, but as I mentioned in the previous slide, it actually increased slightly. Okay, so we talked about dead zones, we talked about nutrients, and all those fun things. So what can be done about these nutrients? So nutrients fuel algae blooms, and those algae blooms will eventually turn into dead zones. So not typically good for water quality. Best management practices to prevent algae blooms and dead zones from occurring is to tackle the source of these nutrient pollutants. So there are what are called point sources and non-point sources. These were designated by the EPA. They identify these two types of water pollution for regulatory purposes. So a point source pollution, you can see a picture here, an example on the left, comes from a single identifiable place. So there's a physical point. You can see this waste or this pollution coming into either a river or a stream. Here so this could either be smoke, smokestacks, outlet pipes, or drainage ditches. So here we have an outlet pipe coming from water treatment plant. You kind of see this bloom here. That would be a point source for this particular pollution. Point sources are typically easy to identify because there is a pipe or there's a smokestack or something directly leading to the source of the pollution, where the pollution is directly going into the environment. A non-point source is not easily identifiable. It can come from many places at once. So a non-point source here is being illustrated on the picture on our right. So we have city streets, suburban development, rural homes, cropland, animal feedlots. So this would be places where there are rich in nutrients, maybe such as a farm or paved areas like city streets. And when the rain comes through, it's washing all these nutrients into the stream. So it's coming from multiple sources. So where it's running into the stream isn't necessarily the point of its origin. So the point of its origin could be, a couple city blocks away from the stream. So these non-point sources are typically harder to identify and manage than the point source pollution. With a point source, you can physically measure the water outflow of it and measure chemicals or whatever nutrients are found in it. With non-point source, you have to be a little more creative in terms of trying to identify where it's coming from. So we're going to talk about point sources and non-point sources here in a little bit. But I just wanted to show you two graphs here presented from the Chesapeake Bay program, looking at nitrogen and phosphorus loads going back from 1990 up till within the last decade. So nitrogen and phosphorus, they are two different nutrients and they have different chemical masses and things like that. Nitrogen is by far a lot more prevalent than phosphorus. Nitrogen is a lot more prevalent within, fertilizers and things like that. It's very easily dissolvable within water. Where phosphorus tends to be more stickier and stick to rocks and things in the bottom of streams. Anyways, we can see that there have been some dips and increases in nitrogen and phosphorus over the years. Within the last couple years, there's been some slight increases in both nitrogen and phosphorus. Some of these increases, decreases also have to do with rain. So if it's been a wet year or a lot of rain and things like that, washing these nutrients into the streams, there's going to be a lot more nutrients in those streams. Years that tend to be drier, with not so much water flow, tend to have lower nutrient levels. Okay. So we talked about nutrients, we talked about dead zones, and next I want to talk about, Pennsylvania's relationship to the Chesapeake Bay. So we are your northern neighbor to the north, just slightly north of all of you. Pennsylvania doesn't directly touch the bay. However, a lot of our waters go into the bay. So Pennsylvania contributes approximately 44% of the nitrogen load and 24% of the phosphorus load to the bay. So all the surrounding states, Pennsylvania, we contribute a good portion of nutrients to your bay. So most out of any state, Maryland included. So this has led to programs within Pennsylvania and the surrounding states of the Chesapeake Bay to reduce their nutrient load. One of the sayings from the Department of Environmental Protection in terms of trying to reduce the load of nutrients into the bay is what's great for PA is good for the bay. So to try to help form a partnership here. So we're going to talk about a major river that goes into the Chesapeake Bay, and I'm not going to spoil it. Michael, can you pop up question 3, please? So what is the bay's largest tributary? Is it Susquehanna, Potomac, Rappahannock, or York? Didn't realize this was going to be a geology or geography lesson, huh? All right, so 3 out of 3, Susquehanna. Very good, y'all got it correct. Susquehanna River, largest tributary of the Chesapeake Bay. Where do you think the Susquehanna River, what state does the Susquehanna River go through? Pennsylvania. So, there we go. So a little more geography lesson here for you. So this is the state of Pennsylvania, as you all know. Pennsylvania has a couple major watersheds. So there's Lake Erie watershed, there's the Ohio River watershed, the Susquehanna watershed, Delaware, Potomac. We're blessed with many, many rivers, with 2 major rivers, Susquehanna River being one of them, and then Ohio River as well. So the Susquehanna watershed is not the whole state, little bit over more than, I would say half the state, which goes through a little bit of Western Pennsylvania and a little bit of central, or mostly central Pennsylvania. St. Francis University, where I'm broadcasting live now, is found here in Cambria County. So I'm gonna, I'll talk about Cambria County here in a little bit in Cambria County's relationship to the watershed. But the Susquehanna watershed is very large. Well, it's the biggest one within Pennsylvania. So what we do in Pennsylvania affects the Susquehanna River, which eventually affects Chesapeake Bay. So some fun facts about the Susquehanna River. It's the nation's largest, not the nation's largest river. It's the 16th largest river within the nation. It is the largest river that flows into the Atlantic. All taken together, it's about 444 miles long, and it actually doesn't start in Pennsylvania. It starts in New York. So it starts in Cooperstown, New York, and ends in Maryland. There, and I apologize if I butcher the name of this, Havre de Grace, Maryland. And it provides the bay with half of its fresh water. So the Susquehanna River is a very important river to the health of the Chesapeake Bay. Here's a picture on the right of the Susquehanna River going through Harrisburg, which is, as you know, the state capital. So here's some other facts about the Susquehanna watershed and why Pennsylvania has a big role of this watershed. Like I mentioned before, where it travels through the most is through Pennsylvania. Even though it doesn't start in Pennsylvania, we share a large portion of the river. Looking at the population of the Susquehanna watershed, Pennsylvania, there's about over 3.5 million residents live within the watershed within PA, compared to Maryland, which is 60,000, and New York, which is 616,000. So it's kind of a big deal, big important watershed here within Pennsylvania. We have the lion's share of people living within it. And this data was provided by the Susquehanna River Basin Commission, a lot of times abbreviated as SRBC. So again, looking at the Susquehanna watershed within Pennsylvania, we can break it down into land use here. So about 63% of the watershed in PA is covered by vegetation, so forest. 9% of the watershed within Pennsylvania is developed. So, there's towns and cities and things within the watershed. And then 24% of it's cultivated. So that would be your farms, farmlands, dairy farms, things of that nature. So the majority of the watershed in PA, over half of it, more than half of it, is forested, while only 24% is, used for farmland. So looking at the Susquehanna watershed, and one of the reasons why, I mentioned earlier why am I interested in the Chesapeake Bay. I think it's an awesome place, beautiful area, love going there every summer. Cambria County is at the edge of the Chesapeake Bay watershed here within Pennsylvania. In fact, Cambria County is actually kind of split in half. It straddles both the Ohio River and Susquehanna watersheds. So where I'm at currently right now is the edge of the Susquehanna watershed within Pennsylvania. And if I were to drive home and live in Johnstown, Pennsylvania, and you know where Johnstown, PA is, that is the Ohio River watershed. So if I were to dump fertilizer or a can of Coca-Cola, something like that, the water in St. Francis goes eventually into Clearfield Creek, which goes into the west branch of the Susquehanna before entering the Susquehanna River, and then finally taking it to the Chesapeake Bay. Here on our campus, and some of those pictures I was showing you earlier about the streams around campus lead into what's called Lake St. Francis. You can see a picture here before the snow hit today. And then this water here eventually goes into that Clearfield Creek, which eventually goes in the west branch of the Susquehanna before leading into the main Susquehanna watershed. So what we do here is important. So with the Susquehanna River being vital to the Chesapeake Bay, it became apparent that we need to manage and be careful of the nutrients and things that we are putting into the Susquehanna River watershed. So with that, the federal government came up with what are called total maximum daily loads, a lot of times abbreviated as TMDL. And you can think of a TMDL as a pollution diet. So a TMDL is going to identify the maximum amount of pollution that the waterway can receive and still meet water quality standards. So here is that stream I was telling you about that goes in that Lake St. Francis from the previous slide. Each stream or each watershed within the Susquehanna watershed, so Susquehanna watershed is the major watershed, and we have the Clearfield Creek watershed, which leads into that, has its own unique TMDL. So what is the maximum amount of nutrients when we're looking at phosphorus, nitrogen, and sediment that can be allowed within these streams before water quality becomes compromised? And usually when the water quality becomes compromised, before dissolved oxygen level becomes very low, or you have the risk of an algae bloom. So as TMDLs identify pollution restrictions, as I mentioned, for nitrogen and phosphorus, which are very important with algae blooms, which can create dead zones, and also sediments as well, so just dirt and gravel and things wash into the water. So the EPA allocated different amounts of nutrients that can be different amounts of nutrients that are allowed within different streams and watersheds within Pennsylvania, Maryland, Virginia, New York, Delaware, West Virginia, District of Columbia. Here we're just looking using Pennsylvania as an example, looking at the Susquehanna watershed. It is the biggest watershed within the Chesapeake Bay, so it's allowed to have kind of the most out of all the other rivers. 68.9 million pounds of nitrogen per year and 2.49 million pounds per year of phosphorus. If you were to compare that to the Potomac or the Susquehanna in Maryland, which Maryland doesn't have much of the Susquehanna River before it empties into the bay, it's going to be a lot less. So the lion's share of nutrients are coming from Pennsylvania, and we have a higher TMDL to reflect that. So what is the criteria for basing these TMDLs? EPA and government agencies, what they looked at was how big was the watershed, how large are the rivers, and they do testing off of a couple of different types of criteria. So they look at dissolved oxygen. So what is the dissolved oxygen of this particular stream or this river when it's relatively healthy? Also water clarity. What is the natural water clarity of this stream or stream that's not impacted within this watershed? They also look at chlorophyll A concentration. You may be thinking, why are they looking at chlorophyll A concentration? Chlorophyll concentration is a proxy for the amount of algae that's growing in a river. We actually can get a value from chlorophyll A without identifying all the different types of algae within the water column. And if it's over 100 or 200, the waters may be very productive, which could be eutrophic or allotrophic, which are aquatic terms that I won't talk about in this presentation, but we can use that as an indicator to determine the health of the water. The criteria is different for each watershed in time of year. So winter months tend to be not as productive as spring and summer months. So the TMDLs aren't going to be as high in the winter months. The main thing is levels for these criteria are exceeded. So if we say dissolved oxygen, in order to be a healthy stream, dissolved oxygen has to be a 5 or 5 or greater, and it turns out to be 2, then the TMDL is not being met. So this is important for regulatory agencies to enforce restrictions, saying, well, we need to either reassess the TMDL or there's nutrient pollution somewhere that we need to get a better handle on. So the surrounding states of the Chesapeake Bay, so Maryland, Virginia, Pennsylvania, and New York was also part of this as well, was to have specific targets and goals met by 2025. So one question is Pennsylvania on target to reach these nutrient limits to better manage the Chesapeake Bay, to eventually hopefully get rid of these algae blooms, which are leading to dead zones? The short answer is Pennsylvania, no, we're not on target to reach the nutrient limits. So here we have some graphs, phosphorus is reaching the bay on the left and nitrogen that's reaching the bay on the right. And by the 2025 target, they want Pennsylvania to have about 3.04 million pounds of phosphorus reaching the bay. Currently, we're at 3.8, so not horrible compared to 1985 when they started to measure these things. It was also double the amount. So Pennsylvania does have a little bit to go with phosphorus. You can also see nitrogen as well. So currently we're at 107.3 million pounds of nitrogen reaching the bay every year. The EPA wants us to be at 73.18. Granted, it's not 2025 just yet, so we're about 2 years away from that. But the EPA isn't necessarily happy with the progress of Pennsylvania and how we're doing with these TMDLs. So we're going to talk about some ways that, or some challenges to reaching these levels for decreasing nutrient pollution going into the bay. So one of the problems is that Pennsylvania is unique with Susquehanna running through, north to south through the entire state, is the largest watershed. Pennsylvania does have many non-point source opportunities. So this is just a fancy way of saying there's a lot of agriculture, a lot of paved roads, things like that are hard to manage. With urban runoff, there are about 315 municipalities. So this would be towns, boroughs, little villages, things like that, with their own water treatment, things like that are putting water into the bay. And then with agriculture, there's about 33,000 farms covering 3 million acres. So a lot of nutrients from fertilizers and just cattle feed and things like that. A lot of those nutrients are going to the bay. So, and another problem is the Pennsylvania Department of Environmental Protection which has been tasked to monitor the TMDLs within these streams. They're also understaffed due to the budget cuts that happened about 10 years ago. So Pennsylvania, it's good, but we still have work to do. So Pennsylvania has proposed some plans of action. So how can we better address this? How can we better drop our nutrient loads even further to help the bay to stay on track for those targets? With agriculture, there's plans to promote soil health. So this would be rotating crops regularly, doing what's called precision fertilizer treatment. So fertilizing the farms at particular times of year, especially when it's not going to be raining a lot, and also what's called precision feeding. Precision feeding is kind of a curious one, and I had to look that up to what that meant. Precision feeding is trying to make specific diets for cows and chickens. So instead of just feeding them all one grouped diet, you can change the diet of particular cows in terms of how old they are, what kind of nutritional needs they need. And this actually can reduce nutrients that are going to be running into streams. And another thing is that the DEP is going to be looking at is what's forestry. So more than half of Pennsylvania is forested. So we do have plenty of trees. However, increase planting trees along streams. So here we have the Susquehanna River. All these gray areas are farmlands. So doing better riparian or buffer zones around the streams around the Susquehanna River. And also converting lawn areas to habitat for pollinators and also trees as well. So any place where you can plant a tree that's feeding into the Susquehanna River, they're saying we should plant these trees. And also have a bigger push to restore stream and wetland habitats. Some other proposed plans of action, DEP is to look at stormwater and wastewater. So again, this is sources of non-point source pollution. So with stormwater, have fertilizer reduction through legislation. So reduce the amount of fertilizer that people put on our lawns or golf courses or farms and things like that. Enforce this through legislation. Plant trees and shrubs along streams, kind of going back to the forestry plan from last slide. And also funding for gravel and dirt roads. And some people may find this odd. Well, why would we want to, have gravel and dirt roads? Gravel and dirt roads typically have less runoff than paved roads. So paved surfaces are just kind of a nice slick surface for water to run into these streams, where gravel and dirt allows for water not to run off as fast and to eventually soak into the ground. Some things Pennsylvania can do with wastewater that they're trying to implement is they're pretty happy with how wastewater is managed. It's already removing a lot of nutrients before this water goes back into the streams. But one thing is to continue to support wastewater treatment plants, expand assistant programs for municipalities where appropriate, invest in, invest more, people that are working within these wastewater treatment plants, and also just invest, increase funding for the DEP so they can hire people to assess these areas. Okay. So in summary, there's still work to do, especially within Pennsylvania. We started this talk talking about algae blooms and how algae blooms are caused by increased nutrients. These algae blooms will can eventually lead to dead zones, and dead zones are detrimental to water health within Pennsylvania and within the bay. So Pennsylvania and the Chesapeake Bay, we are linked, if we like it or not, and there are things we need to do to improve that. The TMDLs do give benchmarks to reach, and also gives one important thing is gives regulatory agencies a means to pursue necessary action. So if these benchmarks are not being met, it can give governments the right to sue townships that are not meeting them for whatever reason. However, Pennsylvania, as I mentioned before, we still have some work to do in order to reach the goals of TMDLs. And then on this slide here, I just have some interesting websites that I highlighted. One's called Eyes on the Bay. It's a bay monitoring website by maryland.gov. You can kind of look at different buoys and things within the Chesapeake Bay, see what the water quality is like. And then the Susquehanna River Basin Commission, they have some pretty neat maps of the Susquehanna River and the watersheds surrounding it. And a lot of the information I got for the Team DL report from the EPA I can found at this site here. And Michael, we have our last question here. Oh, I was supposed to ask this one. Okay, so we couldn't put this question into a Zoom thing, but does anyone know what today is? March 14th. So that would be 3/3/14. So you might be not knowing where I'm going with this. So that's Pi Day. Yes, very good, Pi Day. So the question here is, since we don't have a Zoom link, if you want to type into the chat, what's Maryland State Pi? Anyone know? This is kind of a trick question. Maryland State Pie. Ooh, crab cake pie. Oh, that sounds really good, actually. So it's not a pie. It's actually a cake. So the famous Smith Island cake is the the state dessert of Maryland. So before I gave this talk, knowing it was Pie Day, I Googled, what's the state pie of Maryland? You guys don't necessarily have a state pie, but I guess the state dessert is Smith Island cake, which is a multi-layered chocolate cake with frosting, and probably not very healthy for you. It looks very good. I don't know if anyone's ever had it. I've never had it, but it's from Smith Island, which is appropriate, which is found in the middle of the Chesapeake Bay. All right. Michael, have you ever had Smith Island cake?
I have not. I've missed out on that. Have to take a field trip.
Seriously.
Awesome. Well, thank you for presenting today. We very much appreciate it. And yeah, if anybody has questions, feel free to put them in the chat or come off mute. I'll start off with, can you just tell us a little bit about your research? Like, what did you do with, you're involved with algae. How do you go about like putting those little squares I saw was that in a stream or a river? Or what's the process there?
So thank you. So those were bricks that just cement bricks placed into Spring Creek, which is in Center County, which is also flows into the Susquehanna River. So part of our research was looking at algae and what's growing in these different streams that are impacted by nutrients. So what we were trying to do was come up with the nutrient indice. So if you sampled this type of algae in this type of stream without having to measure the actual nutrients in it, by just looking at the algae, the algae species, you can say, is this stream impaired? Is it healthy? Is it not healthy? The example I like to use a lot is a lot of people typically they've found insects in streams, and they've used like mayflies or dragonflies typically indicate good stream health. So we were trying to do the same thing with algae. One benefit of algae versus looking at mayflies and dragonflies is the algae I was looking at are called diatoms. They grow within 2 weeks. Biotic index, yeah. So they grow within 2 weeks. So if there's like a perturbation in the stream, like an influx of nutrients or things like that, it's reflected rapidly more in the algae versus insects. So, and we were trying to come up with part of the research was to help the DEP to determine if we can use these diatoms for these TMDLs.
And if I'm not mistaken, is that what's behind your head there on the wall?
Look at my beautiful office. Yeah, so these are diatoms. So they're single-celled algae that have a silica cell wall. These algae here, These are from saltwater ecosystems, so things that you probably would find in the Chesapeake Bay. The algae I focused on were from freshwater ecosystems. So the ones on this picture I did see in my samples, but they look. My sister-in-law got it for me for Christmas one year, and I didn't have the heart to tell her, but I never actually saw those diatoms before. But looks very cool.
Absolutely.
Any questions? Anything that I say confusing? See any potential for permeable concrete? And there's excuse me. That is a good question, Mary Beth. Do you see any potential for permeable concrete in order to reduce runoff? Yes. I teach an environmental studies class here, and apparently concrete is a very big producer of carbon dioxide emissions. So after concrete cures, it releases a lot of CO2 in the air. I didn't know that until very recently. But one of the ways around that is to use this permeable concrete, kind of to more tackle climate change, not so much runoff. I don't know how feasible this permeable concrete is, like how expensive permeable concrete is to just normal concrete. I do know one time I was in Atlanta, they had a parking lot of permeable concrete. I think it was for their the Georgia Aquarium, and it looks like normal concrete. I wouldn't known it was permeable unless there was a sign that said permeable concrete. But again, I don't know how expensive or feasible that is, but I think that would be an option to help reduce runoff. I don't know with like cold weather states like Pennsylvania, like if water gets in the permeable concrete, if it cracks it. I mean, concrete cracks regardless. So that's a very good question. But yes, I think it would depend on the climate. And again, I don't know like the price difference between normal concrete and permeable is, but they think that is something that we're going to be moving forward in the future to combat climate change at least, which would be good for nutrient runoff.
Anything else?
Other questions?
Well, awesome. Thank you so much for presenting again today. Very interesting to hear about your research and your presentation here. I'm going to put in the chat the feedback forms, so feel free to check those out there. And again, thank you. I'll keep this open here for a couple of minutes. I know Andrew has to run to another meeting,
Have to go
but we'll keep this up to get it to. And yeah, thanks everybody for coming.
Thank you, Michael, for the opportunity, and thank you everybody for listening to me. Hope you all have a good rest of your day.
Yep. Take care.